Okay, so here is your challenge. You're going to take this car right here. Okay? So you'll probably have to take some data about the car in order to figure out how fast it is going. And you are going to try and drop a ball from, let's say you're going to use 5.5 meters. Okay, so we're going to drop the ball down, and it's going to be 5.5 meters above. And your cart is going to be down here. He's going to be driving along this way. And your goal is going to be to catch the ball in the cart. Now, some things that I'll give you, because if you were in class, you would have learned these things along the way, but I'll give you a couple of ideas. So there's going to be a little laser gate that you're going to put on the ground right here. And so really what you're trying to solve for is what is the position that I want to put this laser at, so that when it hits that laser is when it's going to drop the ball. Okay? So like if this is X marks the spot is where the ball is going to hit the ground.
Okay.
How far from X do I need the ball to drop so that the two will hit? And then furthermore, we'll give you the chance, you can build any kind of catching device that you want and tape it or glue it under the top of here to try and catch the ball rather than just having it hit. If it hits it, that's good. If it catches it, that's great. So we'll work that out. So now, I'm not going to talk to you too much. The constant velocity part, you guys are smart people and you should be able to figure that out. But the way that we would describe the motion of the ball is, if we call it position Y, because it's an up and down thing. Okay, so it's Y position at any point in time is equal to its beginning speed, which is actually, we can get right down to the heart of it. So its beginning speed is 0. It actually makes this a lot easier. It's 1/2 a and then t squared.
I recognize that formula.
So we can even make this a delta y for you, so that makes it a little bit easier. So the change in y position and the acceleration, actually, we can even go one step further. So I can give you the acceleration. If we do our work and you want to work in meters, it's just easy. We can do feet too.
Let's work in meters.
It would be 9.8 meters per second is the acceleration due to gravity. Unlike in Schmid's fantasy land, these are real things that have real dimensions, and so like you could pretend that this was a point and that this was a point, and you might get them to hit. But if you want to catch it, or if you want to give yourself the maximum amount of like room for error, then you really should consider that that's not a point and neither is that. And so you should take those sorts of things into account.
Okie dokie. We don't need a running
go
start.
Get set up.
Oh my god. Okay, so we need to figure out how long the time is, right?
Mm-hmm.
And we have to use that formula, correct? You guys count.
That's how I took it.
We don't have to use it.
So
Because when you said 4.9, when an object drops, after the first second it covers 4.9 meters, because it doesn't reach 9.8 meters per second until second one. You know what I mean? Because it's starting at 0, so it's not going to be released at 9.8 meters per second. It's going to take 1 second for it to get to 9.8. I just know this because we've done this in middle school. So for the first second, it should cover 4.9 meters. And then after that, it's increasing at 9.8 meters per second every second. So if you look at it, 4.9 is pretty darn close to 5.5.
0.6.
It's and now again, we can use this. That confuses me. So we should have some idea of how far, because in 1 second, it should be pretty close to.
1 second is going to equal 4.9 meters. So how are you going to account for the other 0.6? Because you said doubles or increases.
Well, so right now we're at second 1, and the ball is traveling at it's accelerating at 9.8 meters per second. So that's where maybe we've got to go back and use this, but I don't know how they haven't really looked at that. So what we have to get this to equal 5.5.
Well, when it hits the laser, we need to
It's
figure
gonna
out
drop it.
how fast is this dropping? And then how fast does this need to go, correct, to get there in time?
Because it's got two, he said it's got the two batteries in it, so it should be pretty constant. And this is
So how
kinda
far
a
is the
little bit
ball
long and
away from,
Pretty good clip.
like, is the ball just suspended or?
Yeah, it's up in.
It's held on a magnet.
It's on a
Okay.
magnet, 5.5 meters in
Okay.
the air.
Okay.
And the magnet, the electromagnet turns off when the laser gets broken.
Right, and the calculator.
That's gonna run out of batteries in
So-
about 3 minutes.
Can we ask you questions or not?
Yeah, you can ask me.
So am I right by saying that at second one, it will have traveled 4.9 meters? I mean, yeah.
Yes, yeah, you are correct. So at 1 second, 4 points, so it'll be 4.9 times 1 squared. Yep.
And then, so then at that second, now it's going 9.8 meters per second.
Correct.
Because it takes a second to get to that point.
Mhm.
So now we're only dealing with 0.6 meters. But the tricky part is now it's at 9.8 and now it's accelerating. So again, that's how my brain works. I would be very like general with this and I don't quite. So what, acceleration
Yep, that's your 9.8.
and then time, we would put
Time.
1.
And
So that
this
would make
is-
sense.
Change in Y, so how much is Y changing? My change in Y is 5.5. So I was thinking that your 1 over 5.5 has to equal your 4.9 T squared.
Okay. Yep,
So if you take
that
your
will tell you.
5.5 and you divide by your 4.9, like you said, it's gonna be a little bit over a
Yep.
second.
So.
So you have 1.12, and supposedly you have to square root that.
Will our teacher want it rounded any other way?
I did not
Pretty-
use
I
significant
know he's
digits for this
pretty-
cranky man.
I know he's pretty picky on that.
No significant
And I notice
digits.
he's got his
I'm only-
sleeves rolled up today.
I'm only interested in reality, so if it works, then it works, and if it doesn't, then you did it wrong, so.
So, talk to me on this one. How come you,
That should be a 9. So I divided by 4.9. And then I square rooted
Oh,
to
it
get
was-
rid of the square.
okay.
And like you said, it was
Yep.
just going to be over, and you said it's going faster,
Mm-hmm.
and we just couldn't figure out how to do that proportionally. I don't know how to do that proportionally at all. And so
I would
I
have to
did
do
that,
it
which makes
mathematically.
sense. So you're talking 1.05, so is it just 1.1 second, because it's going that much faster? I mean, 0.6,
Because you wanted to catch it,
yeah.
so it, maybe you would want it just a little bit. Because if it would get to that right here, then maybe we wanna. like,
So we
maybe-
need to figure out
Need to figure out.
fast, how fast is this going, right?
Yep.
Because we need to figure out how much time it is here. And
So how long?
we need, like, it's gonna hit the laser here, but we need to account. Don't I need to know the distance, not the time?
That's what X is. We use a T if it was going to be a time.
Well, I know, but,
Because see, we don't use X for just everything.
but you are specific, oh, am I setting up the laser or are you setting up the laser?
We have to, right?
You're going to move the laser to where it needs to be.
Oh, I was thinking you had it there, I thought the laser was the given. No, let's do this, man, we gotta measure this.
Well, so the laser will go as far back as the distance the car will travel in 1 point.
Think of it as being a gate. It's
Yep.
like a finish line. It's like a tape, only it's a laser. When the car travels through that tape, then it's going to turn off the magnet. And
Alright, so we need to measure this baby. Well, how come you don't have meter sticks instead of yardsticks? Never mind, you have meters on the other side. Ignore the sarcasm.
anything else that you'd like to talk about?
I've got issues, what can we say? This is 1 meter. You need another one? I got
That's
another
on Phil. I'm glad for that.
one.
Alexa, good morning.
You know, eventually he's
speaker's
going to
on.
move that against, hold that against you.
I know he is. He's gonna use it in class.
I had a discussion.
And
Are you being taped here?
Okay, what are we measuring here? This is 1 meter, that's 2 meters.
You're measuring the,
Well, we have to measure how fast this
So
is.
you have to measure
in
how long it takes to go, or how far it goes in one point.
Should we start it here and just measure how far it goes in time, what it is in 1 meter? And then we can do, what would your ratio be? Okay,
Well, what-
my speed is distance over time. So my distance is 1 meter. I just need to know how much time it takes to go 1 meter, right?
Yep.
You ready? You guys are both timing so we can collect data?
It's tough to do it when you got to get exactly at 1.1. That's the tricky part.
Well, we don't have to figure out the 1.1. We just need to figure out the rate and then we can do a conversion to the 1.1, right?
So you're going to start it there, and then you want us to stop it here.
Yes, that would be your
Okay.
line. Right? Does that make sense?
Yeah, that makes sense.
Makes sense to me.
Okay, how do you
If-
start this?
If the traffic,
The switch is on the
Oh,
side.
got it.
if the car can keep a constant speed.
All right. Ready? Oh, we got to figure out how we're going to say it. Am I dropping this on start? 3, 2, 1, go? And we start the time on go?
Sure.
Sure.
Yep.
All right. 3, 2, 1, go.
Oh, we did not say, are we doing the front of the car, the back of the car? What do you
Ooh.
want? What do you want
What
at
did
1
you do?
meter?
Front.
I did the front.
I did the front too. What did you get? I got 2.45.
Yeah. I got 2.5.
So really, we can
Still.
do the front. I mean, really, we should do the middle,
Right, because that's where we want.
or maybe like depending, if we do this, like maybe like this point right here.
Because
Okay.
we kind of want our thing to be a little bit bigger because it bounces around maybe a little bit.
Yeah, so, well, he's got this marking here. Should we use that marking? He's got a black mark right here. This would be smack dab middle.
Sure.
All right.
Here, I'll make it bigger so we both can see it. How can you not have fun playing with cars all day? Granted, the only reason why he's got this subject is because math figured it all out. But that's all right. He can feel good about playing with cars. All right, 3, 2, 1, go.
I got 2.47.
I got 2.56, which I probably was late.
2.47, 2.56.
Do it again. And then
Yep.
we can-
Do it again. Round 2. 3, 2, 1, go. Ooh, I did not set that one up completely.
Now I got 2.4.
You're doing the black line, right?
Yep.
I got 2.63. I'm getting slower. Do one more.
Do you think there's an easier way to measure? Because you are accounting for human error.
Here's the other thing. You're going to have a box on it now. I don't know if that's going to slow it down at all. Maybe we need to make the box first, put it on it, and then
And
measure
then
it.
do it.
Oh boy. Okay. What are we doing here, kids?
Don't you think so, though? Because
Yeah, I agree.
if
Yep.
it would slow it down at all,
Yeah.
so...
All right, we're ready to roll.
Oh,
No!
where were you? We were looking
What
for
did I tell you? So,
You said whatever.
You said...
You said
Say whatever.
whatever.
You said it has to be
Just
something
the
to
bum.
catch it.
Did you have a...
the design may not permanently alter the buggy in any way.
It's
It may
not
may not hamper its movement.
Nope.
Nope.
It may not enlarge the footprint of the buggy.
Oh!
We were just kind of goofing around. We thought this would, okay.
Pretty
Come on!
bunch of comedians. Bunch of comedians.
All right.
That just goes to show you we didn't read the back.
You got it all worked out?
Well, we
figured
thought
this.
we should probably be doing the time with this on in case it alters the buggy.
Okay.
Would this be outside the footprint? I hope not.
Well, it is a little, but you know what? I'm going to let it go.
Okay.
We're a special group.
Tell you what, that's
That's pretty good.
pretty solid.
Masking tape and duct tape. Who could ask for more?
So now we're
We're back to timing.
okay.
We got to figure out what our rate is. All right. So now this is going to. We have to figure out what are we timing off of. Hits the front, the center, what?
I don't know, we need another mark now.
Yes, that's what we
Because
need
you
to mark.
covered up the other one.
Should we go 1/3? So that way if we're a little bit late, it still makes it in.
So,
Should we go halfway? If we're late, then it could end up in the
so the
back.
beginning of the card is gonna trip the ball.
Beginning of the card's gonna trip it, but at this point now, when it trips it, it
It's
can
gonna
now
take-
hit in the,
Well, it's got a 1.1.
Right, 1.1. So
so where do you want to time? Here, 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 here.
Really, what we need to figure out is so we need to know how far it goes.
In 1 meter. So then we can use just a ratio to figure out
Doesn't
1
it go
point.
1 meter in 1 meter?
This?
Says
Is this-
how far it's to go in 1 meter.
How much time? How fast? How fast can go 1
Just-
meter?
But we need to
Sorry
figure-
for the poor. Yep,
we
you're
need to
right.
figure out that when it trips this,
It's going to, after it trips it, it's going to take 1.1 second
for it to drop.
to drop. Do you want to measure 1.1 second and figure out the distance? Is that what we want to do instead?
So really, we're looking at about a second. So we need to figure out how far this goes in a second. Do we do that?
No, we are doing how far can it go in 1 meters.
Okay.
Because to
Yeah.
measure for 1 second, we're going to estimate where it is. But we can do that. That's also good.
Just gotta. Yeah,
but you still have to figure out where you wanna, because the front triggers it.
Because we can do how fast it goes in 1 meter per how many seconds and then do a conversion and we can make it down to the 1.1 or we can just measure how far does it go in 1.1. Oh, the reason why I did the meter is because this is in centimeters and I didn't want to do conversions. I was cheating. I should have clarified that. So the reason why I was working with meters is because he has this marked in meters and I didn't want to work with silly how many centimeters are in a meter. Is that what you want to do?
yeah, I'm just thinking we've got to figure out how far it's going to go in 1 point. You know what I mean? Because really,
Do you realize there's only 3 countries in the whole world that are not in the metric system?
I know.
3, that's it.
just wait, I just want to mess with something else. See, this is bad because I don't use math, but so how are you going to figure out? Again, you're just going to put the ratio in there, and that will tell you.
Speed is distance over time. And my problem with measuring 1 second is because when you say 1 second, then I have to, like somebody has to measure that. So when your eyes are at 1 second and then you say stop, and then I'm a half a second behind, like how do we get an accurate time versus this?
Yeah. Okay. Well, I got an
I'll also
idea.
tell you the same thing that I tell
I got
my
an
students
idea.
when it comes to timing things. So, and you should know this too. So, you are looking at 1/10 of a second of error on average. If you're really good, maybe slightly less than 1/10 of a second of error at the beginning and at the end of any time you use a stopwatch. So, really, what I tell my kids is timing anything that lasts longer than 3 or 4 seconds with a stopwatch is meaningless. Because the error that you bring into, so you're trying to time something that lasts 1.1 seconds with a stopwatch. I'm telling you that there's 0.2 seconds of error in your measurement of 1.1 seconds. So you're talking like, around 20% error.
So you're saying we're more accurate when we measure for longer time.
I'm just saying that you should think about what can I actually measure reliably.
Then let's measure
And
the
I
1
don't think that you
meter.
can lay this thing down on the ground and stop it at 1.1 seconds and say that what you
Yeah.
did there you're probably off by up to 20%.
We could do what
Right.
we did last time when you had that,
Oh, the clicker?
Yeah, let's work the math as long as you know.
Or just let it run for a ways and you know.
Yeah.
Well, we can set it up, but otherwise, my only thing is this is in feet and we need this to be in meters and I don't want to do conversions. Not that I can't do
Didn't we
conversions.
convert it last time?
Yeah, we did, it's a pain in the neck.
See? See?
You can.
I was
So
gonna
what's
say,
in-
I thought
what's
we
in
did
set
last
The clicker
time.
so that it clicked once a second.
If we mark the floor, all of these tiles are 1
Okay.
foot. The
I've
problem
got
with
a
it,
long
you
tape,
have,
I mean, I've got like big tape measures, if you wanna do it in meters and you wanna tape, I've got all
can't
that
I
stuff.
just use the meter stick?
You can do whatever you want, but again, I'm trying to tell you, well, I'm not trying to tell you anything.
So if we would just
Because
stretch out an area that's really long in meters and let it run for 10 seconds, then we should know in 1 second, if we divide the distance, what's the average that it goes.
let's do, we need a tape measure for long
It's
meters.
right there in the fart.
Got it. Yeah, got lots of options. 10 meters is even, I think, obscenely long. I don't even know if you can go that long, but you got the right idea, I think. So, this won't work. Work with.
Well, let's go 5 meters then.
Absolutely.
And let's go right here on the floor.
We're gonna go 5 meters. Oh, I love new markers. This is a new one. Markers are always nice. Got it, got it. Here, mark your 5 meters on your floor. Ah, I called the bank. In case this moves. 0.
You got your spot?
Yep. All right, timers, you ready?
All right. So you're gonna say
So are we
go.
timing when the front gets to 5?
Oh yeah, we haven't decided that. What are we gonna do? I say 1/3 of the way. I say where these tape marks are, right here. Because if we're little too early, that gives us room.
Yep.
And if we're late, that gives us more room. Unless you want to split it in half.
Isn't this what we're trying to figure out though? Because we can start the car back any distance we want. As soon as it hits the gate, it's gonna fall.
Correct.
So we need to know how far it's gonna go in that 1 second, and then, so we should mark it from the beginning on 0 to the beginning on 5. Because that's gonna tell us the speed of the car.
Right.
And then we'll be able to know how far to put that gate. That's what we have to figure out, how far
Okay.
to put the gate back. So let's
All right.
you say, we'll go from
Front
the
to
beginning.
front.
All right.
Yeah,
Front to front.
this way. Okay, I'm not ready. I'm ready when you're ready.
All right, we're going on 3, 2, 1, go. 3, 2, 1, go. Oh, we should have put the things down because it's going off track.
Got 12.
I got 11.9. Should we just try it again?
Yep.
You,
Hold on, I've got to write down our numbers though.
Conduits or?
Yeah.
maybe
12, what
maybe
did we
that's
have?
Too far.
He's got
Like
conduits.
3 meters?
I had 12.
12, 12. What did you have?
At 11.9.
11, 9. He's got those, whatchamacallit. He's going to go get them. See? Here's my first one,
This
it's at
is not
0.
gonna be 5 meters though, that's the trouble. It'll get you most of the way there before you have problems, so.
All right.
Okay.
Ready?
No.
Okay.
All right.
3, 2, 1, go. What do we got?
I got 11.56.
11.4.
Ooh,
How about 11.5?
11.5. Let's go with the 11.5. So we have 11.5 seconds.
And 5 meters divided by 11.5
Is a smelly marker.
Is 0.43.
So 1 meter in 0.43 seconds. What? No,
Doesn't
no, no, no,
make
no, no.
sense, yeah.
No, no. We want to take this, not that this is the good conversion. We want to take this, are you smelling marker?
No, I just,
Don't we want to take this in seconds and change it to 1.1?
yeah, we want to know the distance.
So what 1.1 times what will get you 11.5? So we want 11.5.
Yep. So 11.5 equals x over 1.1. Is that what you're doing, or?
Well, I think 11.5 over 1.1 equals x. You could do either way. Both of them are equivalent equations.
Okay. You are the math teacher.
10.45.
That's why you're here.
So 10.45 you got?
And what is
So
that?
meaning if you divide this by 10.45, you have to divide this by 10.45, because what you do to one part of the fraction, you have to do to the other. And if I use my previous answer on my calculator, that'll get even more accurate. So this is 0.478.
0.47 what?
Well, the car will go 0.478 meters in 1.1 second.
So then that's how far we have to put the gate
Back.
back.
How accurate can you be on your gate back, sir?
You're gonna put it down, I'm not putting it in.
Oh, okie dokie.
If you fail this, it's gonna be all on you.
0.478.
Anyway.
Which is about right, because when I just did it, eyeballed it, I thought it was somewhere around 5 and 6. So. All right, hey, let's.
Okay,
I'm
ready to move over to
I'm exhausted. So.
testing. So hang on. Maybe I can take this here. And I don't know. Do you want to because they probably couldn't see it real well. Do you want to just
Talk through it?
talk through it or not?
We use an equation.
Remember, when you're talking.
Define, what's this equation for, sir? Is acceleration?
Well,
Constant acceleration.
it's for a distance during constant acceleration.
Constant acceleration.
Mm-hmm.
And
Starting
so we plugged in our 5.5 meters, went in for change of y, because that's how far it has to change. Solve my equation, divide by 4.9, square root to get rid of the square. We got 1.059 seconds. So we're going to round to say 1.1.
How did you know that it was 1.059 seconds? Because it looks to me as though it's naked as the day it was born. 1.059.
Make it
So-
numbers.
Because I'm going to go and identify my variable right now.
Sure.
T stands for seconds.
No. T stands for time, usually. And you can measure time in hours, years, months, decades,
What?
centuries,
Oh.
whatever.
So you're being kind of persnickety about the fact that I was exact in my measurement.
All I'm saying is, you've got...
T is time in seconds.
Okay.
Y is distance in meters. All right, so if we have the square root of 5.5 over 4.9, 4.9 is seconds, 5.5 is meters, and we have, we times, I have to explain that. This is meters per second, meters per second squared. Meters per second squared. So meters are going to cancel out. Square root and the square are going to cancel out. Seconds is left, so I'm left with time. Then we have speed is distance over time. We took a little while and we figured out ratios. So our distance was 5 meters. Our time we figured out was 11.5 seconds. But I need it to be this time. So I need to figure out what can I divide by to get that time of 1.1. And rules of fractions. If you divide the bottom of the fraction by that, you have to divide the top by the same thing. So we have to be back 0.478 meters.
So the laser will be 0.478 meters from the impact spot. Go ahead.
We want You
You got,
made
you
a
got,
bouncy.
you would have gotten full credit.